Be very gentle.
Oh.
This is a very old unit. Probably older than some of you. This is maybe an 01. Yeah? Y'all all born probably after that?
97.
97? Okay. Everybody else probably 03 or something? 02? 05? I forget what year we're on. Okay, so this thing's pretty old. We are looking to get a new one. Unfortunately, y'all will not be able to get to use it, but this was on its kind of last legs. I just want to tell you beforehand. We've already had to redo part of this stuff over here. I had a TA, David, who's really good with electronics, and able to rewire this thing back up. So part of the stuff we're going to be doing here, part of the stuff we're going to be doing here, and the other part's going to be on the computer. Okay? So it's not computer controlled, but they do have computer outputs. The new ones are computer controlled. That's what we're looking to get. So, and that old computer is when running Windows XP. It's not the fastest thing in the world. Hard drives are old. You're going to have to take your data off with a flash drive, so make sure you bring that. Okay. When you save stuff, make sure you save it to Excel like 5.0 or whatever the newest one is, because it's hard to, you have to come back, you have to resave it, reopen it to try to get all your stuff to open back up, so just make sure you do that right the first time. So just make sure whoever's operating the computer, Excel 5.0, and bring a flash drive. Okay? We'll turn that on. Actually, we'll start it up now. By the time I finish, we'll probably be done. Yeah, you got that thing boot up? Used to be state of the art. Okay. Where are we gonna start this thing? We got a lot going on in here. There's a unit that you all see in the back corner. That is not for us. That is a autoclave. These work the same way as they do for the pump lab, right? So this is on. These are off. This one needs to stay on at all times. Don't ever turn this off. Also, don't turn the water off over here either. All this stays on, because that thing, when it needs water, it needs to be able to get it. So for us, if you need to wash your hands or just get extra water, let's say to fill up the water reservoir, which we'll talk about later, just open this one up, and then this one will supply the water to the unit. Okay. So don't ever turn this off, and don't ever turn this off. Just leave those on. Okay. Just operate with this. We have two exchangers. We have a plate and frame. Right. I think specifications for them are in the lab. The amount of frames and the heat transfer area and stuff like that should be in the lab manual. We have a small plate and frame. Then we have a small shell and tube where it's actually acrylic and you can actually see the tubes and all the water flowing through and stuff like that. So our main the main objective is basically we're going to be determining heat transfer coefficient. So you can have your overall heat transfer coefficient that we can get from experimental data. And then you can also calculate them from the theoretical calculations too. You're going to need to have both of those, and then you can compare them. Make sure you have the equations you're going to use for both of these for the pre-lab, because Dr. Ashley's going to be looking for them. Okay. So you have theoretical calculations for your shell and tube and your plate and frame, and then you can have like your LMTD method to use your experimental data to just get the overall. And you'll be comparing those two together. So that's basically the objectives for this experiment. Okay. We're going to try to get duplicates if we can. Whatever exchanger we start with, we'll definitely get duplicates for that one. So we'll run through all the conditions, restart it. Then we're going to swap it out with the other one. We should be able to get one set for that one. If we can get duplicates, we can. If we're running short on time, is what it is. We'll just have the one run. This is probably the longer experiment, I would think. So you probably are going to run to the end of time. That's why we started this one first, I think. So whoever's doing pre-labs, this is usually always number 1. Membrane's always 2, and pump's always going to be 3. So that is the order you're always going to go in. Okay. Let's see. So the lab manual lists the conditions. These are going to be provided for you. So the hot water flow rate is going to be 1 liter per minute, and your cold water is going to be either 1 or 2.5 liters per minute. And then we're going to be changing the temperatures, 35 and 45 C. So there's going to be a little bit of time with the heating to let it heat up or cool down depending on which condition you're at. Again, we only take data points whenever we're at steady state, so you just have to wait until it gets to, and it's cool, you actually be able to see the control system steady out. Once it looks pretty straight, you can just go ahead and take out 10 data points or so and then call it. Oh, what's up? So one of y'all will be over here. Yeah, I don't think there's a password to this thing. You just go. So the software will depend on whatever one you want to use. We're only doing plate and frame and shell and tube, so let's just pick shell and tube. And we're gonna load experiment A. Let's load A. Okay. So you can set whether it's co-current or counter-current. We're doing only counter-current for all of them. So you just click that one. So it has a little diagram, so you can see what your inlet and outlet temperatures are and the flow rates for hot and cold. Okay. We'll be able to set all this up, so we can do. So you want to set this to automatic. That way you don't have to click it every time. You can set your sample in with 3 seconds, 5 seconds, whatever you want. Do continuous. Let's see what else we want to do. We can change this from. So this is going to be your actual data output. So you can actually see it graphically, or you can see it tabular, whatever you want. When you export the data, it's going to basically be this. So you could just copy the. Well, it should be an Excel file. You can just average out, your temperatures and flows and all that. Once you get on this one, you can set this up. So you click the little y equals mx plus c, the little line button. I would take the colds, hots, flow rates, throw them on one, throw those on one and show the lines. Click OK. You can scale them somewhere. Yeah. Graph and axis scales if you want to. If they kind of look weird or something like that, you can always scale them or set a minimum or maximum just to make it easier to see. So you can play with that if you want. Just click apply and OK. And when you're ready to go, you just click the go button and it'll start tracking data. So it doesn't matter for that steady state yet. It's fine. Matter of fact, I like to just use this to determine when that is. And you can just watch the temperature go up. It might overshoot, come back down, and once it levels out, again, 10 data points or so afterwards, you could just call it. You could keep going, and you'll know where the data is at because when you change the temperatures, you'll see it either ramp up again or cool back down. It's like you'll know where the breaks of data at. I would not suggest doing that. I would suggest saving each one, closing out and reopening it, or starting a new one. Actually, closing and reopening it, because sometimes it might do run 1, then it might do a run 2, a run 3, and you have to go back and change these individually. And if you forget to do one, then the data won't show up. I would just close it, reopen it, and just reset it back up. That's the fastest. The reason why I wouldn't recommend going one continuous Excel file, if for some reason a circuit trips or something like that, and it shuts this thing off, and it's not saved, you basically lose your entire day's worth of data. So if you had to redo one experiment versus all of them, I think you would choose just the one, right? And sometimes we just won't even have enough time to do it. You have to do like a makeup lab or something, or whatever Dr. Ashley wants. So I would just do them all one at a time. But once it's set up and go, you can have somebody else, one person set up here. You can click go. Operating, it's all going to come from over here though. So the main power unit's on the bottom. You can just flip that. You should see it light up. I like to watch. I mean, you can kind of look at the flow and the temperatures on here. The flow should be accurate. The temperature on this one's kind of weird. Again, there was some damage to this thing, but they should output that one just fine. So you can have somebody tell you if you're low or high, whatever you want to do. But for this one, it's easy. I think the flow does work pretty good. So I just flip back and forth between hot and cold and just see where you're at. You can just set it, and then you can tell them you're ready. They can start, watching the data, whatever you want. We do want the ambient temperature, right? So we'll have this. This should output to T7. So you can just pick up that one at the beginning. It shouldn't really change in here. Just grab whatever it is at the start. And then we'll have to hook all this stuff up. So the hot water circuit is on its independent circuit. What I mean by that is it's not supplied anywhere. We have a water reservoir that we'll put the water in, and it'll be heated and pumped on its own little circuit. The cold water is actually supplied from this. So I'll come in earlier and run it just to make sure that it starts off super cold, but eventually once it runs, it evens out. If I didn't do that, you'd have a changing dynamic temperature here, which would kind of ruin everything. It's kind of defeats the purpose. We want steady state. So I'll probably come in beforehand, just make sure we get a steady state before you run in, or even average temperature. But we'll turn this on, The cold water control is going to be this gray knob, or you can use the black valve too, whatever you want to do it. This one's the gray knob's a little bit easier to fine tune, but there's two series of valves. The gray one actually used to be an old regulator. That was to minimize pressure fluctuations, but I don't know where that thing's at. That thing's been gone since as long as I did this back in the day. So, but if you want to use the control flow, that's fine. There's two flow meters, one on the cold water circuit and one on the hot water circuit. So the cold water flows in, goes through your valves, goes through your flow meter, and then will enter whatever one of the exchangers you want to. Okay. The exchangers are these are quick connect fittings. They work a little bit different than the air pressure ones. Basically, you just plug one of the tubes in, and then this little black ring. If you want to pull them out, you pull that black ring away from the tube while you're pulling the tube out. Okay, and it should just pop right on out. This one's hooked up. I don't want to take it out, but they all work the same way. So you plug your cold water in. For this one, the cold water inlet's always going to be on the bottom. That makes it significantly easier to get the air bubbles out, okay? Because the bubbles float to the top. So you want the entrance over here, okay? And then the hot water side just depends on the flow configuration. So we said we're doing counterflow, so you just need to make sure if you know the cold water is coming this way, you know the hot water got to go that way, okay? So the inlet tube has to be on this side. And they have little arrows on each one that tells you. So this is going to be the inlet side going to your exchanger. This one's going back into the heater pump combination. This is going to be the inlet, and then the outlet's just going to be this. The outlets, you can just hang them over into the sink and just drain them if you want. We have some graduated sealers to grab some water and fill this up with. The cold side is pretty easy to set up. The hot side is very tricky because, like I mentioned with the pump, you have to prime your pumps. So in order to get all the hot water bubbles out, I'm probably going to help you with this because it's tricky even for me. But there's a way I can set it up to basically use the cold water side to just flush everything out. And then we'll hurry up. I'll probably get somebody's help. We'll hurry up and swap them back up. Fill this with water, get any extra out, and then we can turn the pump on and it should go. This reservoir is pretty cool. When we fill it up, it's actually sucking the water in from the reservoir. So any bubbles that are in the system, once they come back in the reservoir, they should just bubble out. So everything being sucked out and pumped back in should just be liquid. Okay? So that's what the point of this reservoir is for. And we can set our hot water flow rate with this valve right here. Okay? So the cold ones, you can do these. The hot one, you only can do this one. Again, so put your flow configuration. I'm going to help you get the bubbles out. Once it's all set up and ready, you pretty much can go. You won't need me till we swap out. Once we swap exchange, we have to do the same thing, get the bubbles out. This one, the exchanger itself is a little bit easy. The bubbles should just come out. For this one, we may have to lift it up, and we're going to slowly start filling this with cold water, and we're going to kind of tilt it and just let the water level push everything out, and then we'll set it back down. That's the easiest way. But we'll play with that when we get here. Just know that you need to get the air bubbles out, and I'll be helping you set it up. The only thing you're responsible with is knowing which configuration to set it up in. If it's counter current, which one of these have to go on which side, and which one of these go on the entrance and the exit. That's all you need to know. Okay. For this one, I think we usually set. This is going to be your cold water inlet. So you just hook this one up on this side, the outlet, just throw it over on the sink, and then just do the opposite. So this will be the inlet for the hot side. So make sure you connect that one to the inlet side. That's pretty much all you need to remember. Okay. And y'all can take pictures of that. We can put in that direction if you want to, so you'll have the pictures ready for whatever you want to do. But that's what you're responsible for. Is setting up the tubes in the right order, and then making sure that your thermocouples that measure your temperature, right, are plugged in the right order. So luckily they do have a numbered bead, and they are colored. So you got yellow, brown, red, and orange, I think. So they match up with the connections on this side. So just make sure number 1 is in fact the number 1 that you want, and connect it to number 1. That's all that you really need to know. Okay. So when we actually want to turn, so that's just setting it up. Again, we had some damage to this. So the pump and the heater is going to be operated over here. So we have the pump switch is the orange one, and the heater switch is the silver one. We do not run the heater if the pump isn't running. Okay, it's designed to run with liquid running through the exchanger and the pump, because it's going to have somewhere to basically input all that energy into, right? If you only run the heater with no water through it or stagnant, it could overheat and actually damage the coils and other parts of it. So it's designed to be ran with water moving. Okay, so don't ever run the heater without the pump. If you run the pump without the heater, just don't turn the heater on unless the pump's running, and we got the flow rates situated and they're meet our required specification for the lab manual. Then you can turn the heater on. When you turn the heater on, the temperature output and the set point is going to be here. The way to adjust that, you just hold that star, just press down and hold it, and go up or down. Hold it, up or down, and it'll just start to go up or down. Right? You're either going to hit your set point at 35 or 45. That's all you got to do. Set it, and then you can just watch it on the screen. When we set the control parameters up, I think we had based it off of one condition, so it may have a little bit of an offset for any of the other conditions that we didn't use. Not huge, but it might be like 2 degrees off. So like, let's say you want to go to like 35, it may need to be 37 before you actually hit 35. Do your best to actually hit the 35. You're just going to look on the screen and tell you if you're actually at that number or not. So, and you can just adjust this one up or down if you need to, but it's going to be pretty close by just getting the actual number. So just go to 35 first. It should be pretty close. Okay. This thing is actually only reading, if you look at the connection, it's the purple bead to this purple bead. So the other main difference too is that this is controlling the temperature based off of this location. When we actually want, let's say the inlet, let's say we're adjusting for the inlet temperature of the exchanger. That's going to be this number 1, right? So there may be some temperature difference between this point and this point. So even if they are right, that one and that one might just be different, period. So you may have to, even if there was no offset, bump up the temperature a little bit to account for the losses. It won't be huge, but maybe a degree or so. So just remember that the manual, if it says 35, that's 35 on number 1. But the unit is measuring it over here. So just know that there might be some small difference. Just don't get hung up on that. Okay? So we'll have somebody over here operating, you have somebody over here operating, you have somebody over there operating, all work together. And again, once you get going, you hit steady state, maybe 10 data points or so. Tell them we're ready. Y'all can change to the next operating condition. Whether you want to go up in temperature or change the flow rate, whatever you want to do. Okay. Once you're done with that set, restart for the duplicates. Once you're done with that, come get me. I'll help you set up the next exchanger, and we'll try to get through as best we can, as fast as we can. We should get out on time though. This is taped off red for a reason. Don't turn this thing on. Okay. This is one of the reasons why that's over there. I turned it on one time before class started, and it started smoking. All right, the power supply basically went out and was sending way too much power somewhere it shouldn't have been. So that's why we had this other unit. The power supply for that one's in the back. So when we start, you have to hit the surge protector button to turn it on. When you do that, make sure that these 2 switches are off. Right? Make sure these are off before you turn the surge protector on. But turn it on before we start, otherwise you're not going to be able to operate anything. Okay? And then once we're done for the day, because you're the Tuesday section, you could probably just leave it. That way it's already set up for the next section, make it easier. That way we only have to do one swap at a time. I'll probably try to set up one of them before y'all come in too, just to speed it up. If we spill any water, which you probably will, there's a little basin that catches the water. I have a bucket on the end. That valve should be open. Make sure it is so it drains in the bucket. If it looks like it's getting full, just close that. Close the little valve on the end and go dump it in the drain somewhere and come back. If you spill anywhere, we have a mop or we have another bigger mop. It's fine. Just don't slip anywhere. Okay. I kind of have it propped up to make sure the water drains kind of this way. The only other thing, that's about it. So for the Tuesdays group, that's going next Tuesday. So the flow path for this hot loop, all right, it's a little bit confusing. So the cold water is very, very obvious. It comes in this way, wraps around. The hot water loop, so the way that this works is it's a closed system, yet we're varying the flow rate. So how could that be? There is a split in the system that the pump and heater basically always has the maximum flow, which I think is like a gallon, which is like 3.7 liters per minute. It's always got 3.7 liters per minute at all times. This doesn't necessarily have to be the case. So this valve here, the maximum flow through the unit is when this valve is actually closed. Why? Because you're not splitting anything off. So it's coming out of the heater and pump. It's coming in this way, and it's going through your flow meter. And then this is the suction side of the pump is actually sucking it through all the way back around, right? So once it goes through your flow meter and it comes out this way, it's metered right here. So if we want to decrease the flow rate, we open this valve and split the flow back to the heater and pump unit. Okay, does that make sense? So the flow is coming in this way, and can either, when this is closed, only go this way, the maximum flow rate, or we can split some of that flow back off and only send maybe half of it and get 1.5. That make sense? So let's say you're splitting 1.5 this way. The other 1.5, let's say it was 3, right? You're splitting 1.5 this way. The other 1.5 is going through your exchanger and then recombining so that this is 3. So this is going to be 3 and 3, but this might be 1.5 and 1.5. Or it could be 0 and 3, or whatever other common, 2 and 1, whatever it is. That makes sense. Okay? So this valve is actually splitting flow off. So when it's closed is the maximum flow. When it's wide open is going to be the minimum flow. Okay. You're going to probably need to know that for the pre-lab. By probably I'm going to ask you.
Okay.
Okay. That all makes sense. So the water is a pump and heater in here. It sucks it all through, and it comes back out where it then gets metered, and you can split back off whatever. Okay. Yeah. Okay. And just for clarity, like when it does get metered, the flow rate, it is going back to the reservoir. Okay. So there's 2 spouts in the reservoir, one that goes directly to the inlet of here, and one where that water's getting pushed back up. So we're clear. Okay. If y'all want more clarity on that, you can.